How to diagnose ground problems in sensor circuits. This lesson shows how to approach a weak or wrong sensor ground reference can shift signals and create misleading sensor faults. Sensor ground is not just any ground point on the vehicle, it is the reference path the ECU uses when it interprets the sensor signal. Chassis ground may be close electrically, but it may not be the same point the module uses for a low reference. If you measure from the wrong ground, the number can look good, while the ECU sees a shifted signal. The ECU reads signal voltage relative to its reference ground. That means ground is part of the signal circuit, not just a return path you can ignore. A sensor can produce the right change, but if the reference ground is offset, the ECU interprets the signal from the wrong baseline. This is how a good sensor can report bad data. Ground voltage offset shifts the whole signal. For example, a signal that should be 2 volts above sensor ground may look different to the ECU if the ground path is carrying unwanted voltage. Scan data may show a value too high, too low, or implausible, even though the sensor reacts normally. The fault is the reference point. A ground side voltage drop test checks the return path while the circuit is active. Put the meter across the ground path you want to prove, not across random metal. Under load, a weak terminal, corroded splice, or damaged wire will show unwanted voltage. That voltage is stealing the reference the ECU needs for accurate signal interpretation. Shared sensor grounds can make several readings lie together. If multiple sensors use the same low reference splice or ECU return, one weak point can shift all of their signals. The code list may look like several bad sensors, but the pattern points toward what they share. Shared grounds should be tested as a network. Bad ground data often appears as a pattern. A temperature sensor, pressure sensor, and position sensor may all look slightly wrong rather than completely dead. Related PIDs may disagree with physical conditions. When several values are biased in the same direction, compare the scan data to meter readings at the ECU reference ground and at the sensor ground. Compare scan data to the meter from the correct reference. Measure the signal to the sensor low reference pin. Then compare that to what the ECU reports. Also check the voltage between sensor ground and battery negative or chassis ground while the circuit is active. The difference tells you whether the reference path is shifting the data. Mistake to avoid. Do not use the wrong ground reference. Measuring a sensor signal to chassis ground can hide the exact problem the ECU is seeing. Use the ground the ECU uses. Prove that return path under load, and compare the measured signal to scan data before blaming the sensor. Build the test path in order. Step 1. Identify low reference pin. Step 2. Measure signal to correct ground. Step 3. Measure ground drop loaded. Step 4. Inspect connector return. Step 5. Compare scan data. This sequence turns the lesson into proof instead of guesswork. STEP Diagnostics. Guided Automotive Diagnostics.